Hello everyone, I am your friend Shadab Imam and we are continuing our lecture series on operations research. So today we are going to see another variation in the transportation problem, that is the unbalanced problem. We have studied in the introduction of transportation model that the transportation problem can be of balanced and unbalanced type. So let us move on to the question. So here the question says that a product is produced in 4 factories A, B, C and D. The unit transportation cost in them are the unit production cost in them are rupees 2, rupees 3, rupees 1 and rupees 5 respectively. Find the minimum total cost. The unit transportation cost is given in the table. So here it has given in the table where A, B, C, D are the 4 factories, with these are the unit transportation cost, and 1, 2, 3, 4 are the 4 stores. So now we need to understand that in our question it has been asked to find the minimum total cost, and here the total cost consists of transportation cost plus production cost, because production cost is also given. So this is production cost. So what we have asked is to minimize the total cost. So first of all we need to prepare a matrix where we have total cost rather than only transportation cost. So it has been mentioned that for factories A, B, C, D, the unit production cost is rupees 3, 2, 3, 1 and 5. That means to produce 1 unit from factory 1 the cost is rupees 2, to produce 1 unit from factory B the cost is rupees 3 and so on. So if we improve this matrix or modify this matrix, the total cost can be given as, for factory 1 the production cost is rupees 2. That means we have to add in each of this value rupees 2, so that the total cost from factory A to store 1, from factory A to store 2, store 3 and store 4 can be identified. So for factory A the unit production cost is 2, so we will add 2 in all the supply. Okay, so now this will be the total cost, and the factory B has unit production cost as rupees 3. That means we will add rupees 3 here, rupees 3, rupees 3. Similarly for factory C it is rupees 1, so we will add rupees 1, and for factory D it is rupees 5, so we will add rupees 5 here in each of this. So now after adding these values we will have the total cost as 4, 6, 8, 13 and so on. And one more thing we need to notice before solving the problem is that whether the total supply is equal to total demand or not. So let us see. Here we have 50 plus 100 plus 50, that means 200, and here we have demand as 25 plus 35, that is 60, and this will be 80, and 105, this will be 185. So here we can see that the supply is 200 and the total demand is 185. That means total supply is not equal to total demand. So in this case what we will do is we will introduce a dummy column, because whenever we are deficient in demand we will add another column with demand as 15, so that this will become 200. Similarly, if our supply is less, then we will add a dummy row and do the same there. So for this particular case, we can see that we have these 4 columns and or 4 stores, we can say, and we have added a dummy column with the demand as 15. Now if you calculate, the total supply is 200 and the total demand will also be 200. Okay, and the total cost for this total cost per unit for this dummy should be 0. Okay, unless there was a penalty given in the question. In this case, there is no such penalty is given, so we have taken the total cost as 0. Okay, now first is we need to find the basic feasible solution, and to find the basic feasible solution we will use the Vogel's approximation method. So in Vogel's approximation method, we know that we need to have penalties, which is the difference between lowest value and the second lowest value for each column and each row. So we will start from here. Lowest value is 4, second lowest is 5, and the difference is 5. Lowest is 4, second lowest is 9, and difference is 4. Similarly here, lowest is 4, second lowest is 6, difference is 2. Here lowest is 8, second lowest is 10, difference is 2. Here lowest is 8, second lowest is also 8, so difference is 0. Here the difference is 0. Now for the row, we have lowest is 4, second lowest lowest is 0 and the second lowest is 4, so the penalty is 4. Here the lowest is 0, second lowest is 8, so the penalty is 8. Similarly here lowest is 0, second lowest is 4, the penalty is 4. Here the lowest is 0, second lowest is 8, so the penalty is 8. So now we will select the maximum penalty. So here we can see that these two values are same, or these two penalties are coming as same. So we can select any one of this arbitrary. So what I do is select this one, and in this particular row we will select the minimum total cost. Okay, in this case it is not transportation cost, it is total cost. So total cost per unit is 0, so I am selecting this cell and we will try to allocate as much as possible here. So this is 15, this is 50, so out of 50, 15 can be allocated here. So this is 15 is allocated. Similarly, once we have allocated 15 here, that means no allocation can be done in these cells. So this has been fulfilled and this is equal to 0 now. Now again we will calculate the penalties. So we can see that the column does not change, that means the penalty in the column will remain same, and we will need to calculate the penalties for row. So let us calculate the penalty for row. So the minimum value is 4, next minimum is 6, and the penalty is 2, and the penalty is 2. Similarly here minimum is 8, next minimum is 10, so the penalty is 2. Similarly here minimum is 4, next minimum is 10, penalty is 6. And here minimum is 8, next minimum is 9, and the penalty is 1. So from here we can see that the maximum penalty is occurring here. So we will select now this row and we will see which is the minimum cost. So 4 is the minimum total cost here. That means we will try to allocate as much as possible here. So the demand is 35, the supply is 30, that means out of 35, 30 can be fulfilled. So this is 30. Once this 30 is fulfilled, no allocation can be done in this row, and this has been reduced to 5, this has been reduced to 0, okay, and this has been reduced to 35. Okay, so now again we need to calculate the penalties. So let us calculate the penalties quickly. Let us calculate the penalties for, so minimum is 4, next minimum is 9, so this will be 5. Minimum is 6, next minimum is 11, so this is also 5. Here minimum is 8, next minimum is 10, so this penalty is 2. Minimum is 8, next minimum is also 8, so penalty is 0. And this has been fulfilled. Similarly, we can see that the row does not change this time, so the penalties will remain same here, and this has been eliminated because it has been fulfilled, the supply has been fulfilled. So now again we will select the maximum penalty. So now as we can see that maximum penalty coming here is 5, so we can select any one of this. So I am selecting this one, and we will select the minimum total cost in this column. So minimum total cost is 4. Here the demand is 25, the supply is 50, so we can allocate 25 here, and after allocating 25, no more allocation can be done in this column, and this has become 0. Similarly, this has been reduced to 25. So now again for the next allocation we need to calculate the penalties. So the column this time does not change, that means these values will remain same. So we will calculate for row. Minimum is 6, next minimum is 8, so the penalty is 2 here. Minimum is 8, next minimum is 10, penalty is 2. Minimum is 8, next minimum is 11, and the penalty is 3. So now among these we can see that maximum value is coming as 5, so we will select this now, and in this particular column we can see 6 is the minimum total cost available, so we will select this cell and we will try to allocate as much as possible. So only 5 demand is remaining and 25 supply, that means out of 25, 5 can be given here. So after allocating 5, this will be 0 and no more allocation can be done here. So again we will be calculating, and this will reduce to 20. Again we will calculate the penalties. So we can see that this time also column does not change, so the penalties will remain same, and we will be calculating the penalties for row. So 8 minus 13 is 5, 8 minus 2 is 2, and 8 minus 13 is 5. So here we can see that this has been eliminated because this has come to 0. Two values as 5, so we can select any one of this. So I am selecting this value as 5, and the minimum cost here is 8. So the demand is 105, supply is 20, that means 20 can be fulfilled, and after fulfilling this has become 0 and no more allocation can be done in this row. Similarly, this has been reduced to 85, and now again we need to calculate the penalties. So here we can see that this time row does not change, so the differences remain same, and for column this will be penalty is 3 and 0. This is 3 and this is 0. So now the maximum penalty is here, and we will select this, and among these two 8 is the minimum total cost, that means we will try to allocate here. So out of 35, 20 can be allocated. So 20 has been allocated, this will be 0, and this cannot be allocated. So 15 is remaining here. Now we have only one column remaining, so we does not have a choice now. We need to allocate the remaining in these two cells only. So 15 here, this 15 is allocated. Similarly 70 here, this 70 is allocated. So now this has been our basic feasible solution, and now we will check this basic feasible solution for optimality. So I am writing this in the new matrix. So this will be 25 25 5 20, this is 70, and this is 30, and this is 15, this is 20, and this is 15. So let us see, we have total 8 number of allocation we have total 8 number of allocation, and we know that the total number of independent allocations should be m plus n minus 1. So m is 4, n is 5 in this case. So 4 plus 5 minus 1, that is 8. So we have all the 8 allocations, and these are independent allocation because they are not forming any loop. So now we need to check whether this obtained solution is whether this basic feasible solution is optimal or not. So we will do this by modified distribution method, or we can say MODI method. So in that particular method we will have a set of variables which is u1, u2, u3, u4. Similarly v1, v2, v3, v4 and v5. Now to calculate the values of these variables, we will have to understand that for allocated cell the value of Cij is equals to ui plus vj. That means for an allocated cell, suppose this is an allocated cell, value of Cij, that means unit transportation cost, which is in this particular question the total cost. So the total cost should be equal to ui plus vj. So C11 should be equal to u1 plus v1. And what we'll do is we will select any of the variables as 0 and calculate the value of the remaining variables. So we will select u1 as 0, and we know that 0 plus what equal to 4. So 0 plus 4 equal to 4. Similarly 0 plus what equal to 6. So 0 plus 6 equal to 6. Similarly 0 plus what equal to 8. So 0 plus 8 equal to 8. Now once we have known 8, then 8 plus what equal to 10. So we can easily say that 8 plus 2 is 10. Similarly this is 6. 6 plus what equal to 4. So we know that 6 minus 2 is 4. That is 6 plus of minus 2 is 4. Similarly 8 plus what equal to 13. So 8 plus 5 equal to 13. And 5 plus what equal to 8. So 5 plus 3 equal to 8. And 5 plus what equal to 0. So we can say that 5 minus of 5 is 0. Now we have calculated all the values of variables v's and j's. So we need to calculate the values at the non-basic cell. So we need to calculate the values at non-basic cell as Cij minus of ui plus vj. So here we can see that for Cij, this Cij is 13 minus of ui plus vj. That means 13 minus of 0 plus 3. That means 13 minus 3 is plus 10. So this is plus 10. Similarly here 0 minus of minus 0 minus 5. That means minus plus 0 plus 5. So this will be plus 5. Similarly here 13 minus of 2 plus 4. That means 13 minus 6 is plus 7. 11 minus 2 plus 6, that means 11 minus 8 is 3, or plus 3 I will write. 8 minus of 2 plus 3, that is 8 minus 5, this will be plus 3. Similarly 0 minus of 2 minus 5, that means minus of minus 3 is plus 3. This will be 14 plus minus 2, 14 minus minus 2 plus 4, that means plus 2. 14 minus 2 is plus 12 here. This is 10 minus of minus 2 plus 8, that means minus 6. 10 minus 6 is plus 4. Okay, this, and this is 13 minus of minus 2 plus 3, that means 13 minus 1 is plus 12. Here 0 minus 2 minus 5, that is minus 7, minus of minus 7 is plus 7. Similarly here 9 minus of 4 plus 5, that is 9 minus 9 is 0. And here 11 minus 5 plus 6 is 11, 11 minus 11 is 0. So we have calculated the values at all the non-basic cell, and there is no value coming as negative, that means all the values are either 0 or positive, that shows that there is no improvement in the problem and we will not be able to improve this particular solution. So this will be our optimal solution, and to find out the value of z minimum, we will have 4 into 25 plus 6 into 5 plus 8 into 20 plus 10 into 70 plus 4 into 30 plus 13 into 15 plus 8 into 20 plus 0 into 15. So if we add all these, we will get the values as 1465 rupees. So this is the minimum value of z for this particular problem, and this will be the optimal allocation to obtain the minimum value of z. Now in this particular problem, as we can see that this value 15 units is coming in the dummy column, so this represents that the 15 units from factory 4, the fourth row represent factory D, that means 15 units from factory D are remaining and does not fulfilling any of the demands. So the unbalanced problem shows that whatever value or whatever quantity is appearing in the dummy column or dummy row after the final matrix, this represents the unused supply or the shortage in the demand. So this is what unbalanced problem is, and in this particular problem we can see that there are two zeros appearing, which shows that there is no improvement in the solution. This case is also a case of alternate optima or multiple solution we call it. We will not discuss it detail in now. We will not discuss it in detail now, as we are going to have a separate problem based on the alternate optima or multiple solution. So if you like the lecture, please share the lecture. Have a nice day. Thank you very much.